Welcome to the, I think, sixth or seventh Glassy Hour now. We've been consistently doing them now since a few months. And as you already saw, if you're here, probably, we launched a new special series for the Hyperdrive Hackathon, the Glassy Hours Hyperdrive Edition. And in our first Hyperdrive session, we're having Jonas from Solana Foundation, who's a DevRel, talking about the gaming track. So they'll hopefully prepare us on how we can start off if we want to build for the hackathon for the gaming track. So if you're interested into that, you should definitely stay till the end. And I don't really want to take any more words and just give it to you.
Yeah, hello everybody. Today I'm going to talk about game development, especially on-chain game development. And this talk will be a bit more technical. And there will be another introduction workshop later this week in case you're just starting. But you should definitely be able to get something out of this. So, intro. I'm Jonas. I was a game developer for 15 years. I worked on games like Forge of Empires, Lost Survivor, World of Kyoto. I worked a bit on the Unity SDK. And now I'm working for Solana Foundation, and I was mainly working on the game examples and recently also the deepen examples. And yeah, here's a quick introduction of all the things I want to talk about. I have 70 slides, so it might be a bit too much actually. But first, we're going to go over why on-chain games, like why I think that's a cool thing. Then I'm going to talk a bit about compression. Then about Solana paid transaction requests and how you can use them for game development. Then a short section about the wallet adapter. Then how you can improve your transaction performance to get as much speed out of Solana as possible. Then we're going to talk about automation. Then I'm going to talk a bit about on-chain events because it's very important for games how you can have certain events and then you then show them in the game. Then something about randomness, because many people want to build gambling games, and so I want to make a session on it, especially on the security of it. Then we're going to talk about big accounts and zero copy. Then I'm going to show you how to build a grid, and then if we still have time, we're going to look at some open source example games and maybe play a few of them. But we need to go quick. So, why on-chain games? So, I think everyone here knows Solana, so it's very performant. It's cheap. Transaction fees are below 1 cent. They usually confirm within 400 or 500 milliseconds. So this enables a bunch of games to be built on chain. So for example, if you Rust, recently I played League of Legends online on my phone, and I had a ping of 800 milliseconds, and I was still able to play it. So, and if you have like 500 milliseconds, then you can already imagine like most of the things, if you have enough prediction in the clients, you can theoretically build completely on chain. Of course, it's not really good for like shooter games or racing games or so on, but many things can be built. Everything that's round based, everything that's strategy games, anything that is like built on a grid, for example. And then you can, of course, reward your players with NFTs, with tokens, and you can also use NFTs to gate the players to your game. So you can say, only people from my NFT collection should be able to enter the game. And then you can already monetize like this a little bit. And rewarding players is nice. People like to collect things. When you're on holidays, you like to collect something, bring it back. And here it's the same in the game. If you get some cool items, then you can have them in your wallet. And later you can also trade them on decentralized marketplaces, which is nice, of course. Then the on-chain game space is also composable. So there are a bunch of people who build programs. So there was, for example, someone who built a high score program that you can use, or there's a bunch of trading opportunities out there. There's open source marketplaces that you can just integrate, or you just take your NFTs and you trade them on some other marketplace that's already there. And another nice thing is like people can build a client for your game. I don't know if you ever played Dark Forest, for example, or any other on-chain games. As long as you have the IDL of the game, which is a JSON representation which shows you how you can call the program on-chain, then you can basically build a different client for the game. So a bunch of the games I will show you later, they have a Unity client and also a JavaScript client, and different people build these clients actually. And yeah, you can take and trade your items, like I already said. And it's free for all. So it's like a backend infrastructure that's just available there. You might have recently heard about the Visa news. And the coolest thing about the Visa news, in my opinion, is that they could just do whatever they want with the chain. Like they didn't need any help from Solana. And it's the same for a game developer. You can just take it and use it, and it will always stay there. So, for example, I played some online games when I was younger, and at some point the servers just shut down, and then my characters were gone. And if this would be a frozen program on chain, then I could now just go there and build my own client again, for example. Another thing that I like about building a completely on-chain game is that I don't need to take care about user authentication. So people come in, they just connect their wallet, their browser wallet or their mobile wallet, and yeah, you just use the public key of them as authentication. Then they sign a message, and then I don't need to care about having emails, having passwords, and all that stuff is basically handled by the chain. I was wondering if this is recorded, should I maybe put my face here somewhere in the corner, or is this like done by the?
The cameras will be included in the recording, so no worries.
Oh, cool. Yeah, and then yeah, probably the coolest thing is that it's like replacing your payment provider. If you ever build a game for iOS or Android, you know what a pain it is to set up these in-app purchases. And also on iOS and Android, usually you pay like 30% fees. And all of these are gone now if you just use the browser wallet. There's also fees if you, for example, implement PayPal into your browser game, and these are not there anymore. So currently, it's still very difficult to get your game into the App Store, into the Apple App Store, because as soon as you have an NFT and you give this NFT some functionality in the game, then you need to purchase this NFT via in-app purchases. That's their rules currently. But this might change in the future, and in the meantime, we have the decentralized App Store now on the Google Saga phone, which is really cool. I just last week recorded a video on how to submit your game there. It's very easy actually. You just take the APK, then you follow the instructions they have, you mint an NFT, and then you can get into the decentralized App Store of the Saga. So it's a big opportunity to publish your game currently. And another one is the X NFT. It's a wallet on Solana. You might know it here in this call maybe, but not everyone does. And you can just submit your game as an X NFT, and then it lives basically in your wallet, and in there you can play it. So I would say currently it's a very good time to start building an on-chain game. And yeah, especially I'm gonna talk about this from a developer perspective today, not necessarily from a gamer perspective. So from a game developer perspective, for me already it's like getting easier to build than normal. If you, for example, also compare the cost from Firebase and Solana, Solana is rapidly getting closer to the same cost as Firebase already. And yeah, you have this platform independent payment provider, which is of course super nice. And you have multiplayer out of the box, because if you have an account on the Solana blockchain, it's public, and you can just use a WebSocket connection and from multiple game accounts listen to the same account, and you already have a multiplayer game, which is way more expensive and difficult to do with traditional solutions. And you don't have the user management. If you compare the tech stack from like traditional games or companies, they're usually very big. You need like some kind of databases and all that stuff. And now you can build a game with just using Anchor and Unity, for example. And on Solana, we have the localized fee markets. So on Ethereum, you have a thing called a mempool, where all the transactions go in, and then step by step, the validators like process these transactions one after the other. And on Solana, we have, and this means that when there's like a big mint on ETH, then all the transactions want to go in at the same time, and then it becomes super expensive. And on Solana, we have a thing called localized fee markets, which means when a bunch of people want to write to the same account, then the fees for this one account on this local market can be increased instead of the whole one. And since you put in always all the accounts on Solana in every transaction that you want to use, Solana can parallelize all the transactions, which makes it extremely fast. So here's some takeaways: fast confirmation times, low transaction fees, no mempool, executed programs in parallel, and ideal for high performance applications. So now we're going to go through a few things that make Solana especially unique for games. And one of them is account compression. You might have heard already of the thing called compressed NFTs. So what I want to show you quickly is this website here. where I can select a color and I can just go in here somewhere and I can click. I need to zoom in a bit. I can click and now I'm buying this pixel here. And the cool thing about this pixel is that this pixel is actually a compressed NFT. So this page here consists of 1 million NFTs. And as you can see, there's already like 80,000 minted or so. But you can see that there was actually no balance change in my wallet. So these compressed NFTs are extremely cheap. This means that for games now, you can mint every character and every item in your game as an NFT, and it will basically cost the player nothing. So this is a huge opportunity, actually. Oh, I'm just seeing something in the chat here. Is it something I should answer? Won't take 30 minutes. Yeah, I will. In the end, we will definitely have some time for questions as well. So yeah, this is compressed NFTs are a big opportunity for games, I would say. Another thing I want to show you is a thing called Solana Pay Transaction Requests. And for that, we're going to go into a little not metaverse. This is 3land. And in 3land, I can walk around. I have this little character. All the characters are NFTs. I can do this fun little ninja walk here. And what I can also do is I can just put an iframe at the wall. And this iframe here consists of a game, actually. It's a tug of war game. And as soon as I now start scanning these QR codes, I can sign certain transactions with my phone. And the cool thing about this is that we can now all together play this game. So if you start scanning these QR codes here, I don't know if it's big enough on your screens, but maybe I can get a bit closer. Then we can actually play now a tug of war game, and the winner will get 0.01 sol here. So I see a few people are already pulling to the left, so I'm gonna winning team switch and like join in there. So now we are at 7, now we are at 6. And this is something like an on-chain game which you could expand on. This is open source. And you could, for example, now instead of just having 2 QR codes on left and right side, you could make like a space game, for example, where you have like 3 spaceships on the sides. Every one of these spaceships has 1 or 2 QR codes that you can scan for shooting or shield or something. And then you could build like a real cool multiplayer game that you can play in a stadium on the big screen or at a hacker house or something. So yeah, these Solana Pay transaction requests are really cool because not many people know that actually you can just scan a QR code and sign any transaction with it. Many people just think it's only for payments. But what these QR codes do is they sign a transaction on the Tug of War program. And I see we are all pulling in different directions, so no one is winning currently. Yeah, but what it does in the program is actually it just increases and decreases the counter, and it goes either to the left or to the right. So I'm not sure if we're gonna manage to finish this if we are not pulling on the same side. So I'm now going here to the right. Don't want to make it too long, but I also would like someone to win. Okay, now we're at 3. 3. Okay, now someone is pulling another. Okay, never mind. I will leave this game open. You can like visit it by visiting 3land, or it's also on a website. And okay, now it looks like we are finishing it. Okay, the person who is doing the last pull now will actually win the money. And yeah, this gives you some opportunities, and now someone can scan it to restart the game. I will show you another game later which facilitates these QR codes where the audience of the players can actually join in. Like if you, for example, think of some esports events, then people could scan QR codes to drop bombs on the field or something like this. Another thing is the Solana wallet adapter, which is amazing. I can use it from many different resources. So there's of course a JavaScript implementation, but I can also use it from within Unity. And the nice thing is that it supports, I think, all Solana wallets in the browser and also on mobile. So now if I go to a website which has the Solana wallet adapter implemented on my phone, I can actually on iOS it does deep links to the wallet, and on Android it does some socket connection to the wallets, and on Saga phone it even uses the seed vault. And this makes it like that you can deploy your game once and then just play it on all kinds of platforms. So if you have a website which has the wallet adapter, then it would open it, for example, in the in-game browser of Phantom, for example. So yeah, definitely check this out for your game. Now I want to quickly go into how you can increase your transaction performance. Like if you have a game and it's an on-chain game and you rely on every transaction to be on-chain, then of course you want to have them as quickly as possible. And some things that you can do is you can use a WebSocket connection. So usually what you would do is like you send a transaction, like you get a block hash, you send the transaction to the chain, then you maybe start polling when it's done, or you wait for the confirmation. But what you can also do is you can open a WebSocket connection to the account that you are actually interested in. Let's say I have a Solana 2048 game and I have the board. And as soon as I have a transaction done, I want the update. So I can just do connection on account change and then put the address of the account, and then I get the update of this account actually as soon as it changes. So I'm gonna show you this a little bit later as well. And then you can also cache the block hash. The block hash that you need for any transaction is actually valid for quite a long time, around 30 seconds. And if you get this block hash before you send the transaction already, you could, for example, get it every 10 seconds or something, then you save the time, like the round trip time to the RPC and back to get this time, to get the block hash, and then you can send the transaction out immediately when you want to send it out. So this also saves you a few milliseconds. Then there's a new technology from Triton, which is called Whirligig WebSockets. What they do is they have a staked validator, which of course gets the shreds from the new transactions faster. And then they have the RPC node actually in the same data center, which makes it even faster that you get the transactions. And what the Whirligig WebSockets do is they give you mid-block updates. So while the block is still produced, as soon as the account changes, you will already get the updates via WebSocket. Another thing that you can do is for your transactions, you can have different commitment levels, right? Usually you have like finalized, confirmed, and processed. And usually if you would probably stay with confirmed because it needs one confirmation, takes around 450 milliseconds. It's often good enough, but you can also use processed, which means that you get the first validation of your transaction even earlier. And the only problem is that some of them or some of these transactions may not go through. So if you use the processed commitment, then you need to do some rollbacks in the client in case you have an outdated state. Another thing you can do is you can predict stuff in the client already. So what that means is I press the right button, I already let the character walk, I do the transaction in the background, and as soon as my character arrives at the position I want him to be, then yeah, then it's already done in the background, and then the client it's already there. And then of course using a custom RPC node, like the mainnet and the devnet RPCs are quite slow, and there are some like QuickNode, Helios, Triton, Hello Moon, for example, that you can check out. Now I want to talk a bit about automation, because often in games you want to do things on certain time intervals. So for example, I want to pay out my rewards of a high score every weekend at 12 p.m. So for that you can, for example, use a tool which is called Clockwork. They recently stopped maintaining the protocol, but it's still available and still usable, and there might be another maintainer later. And how it works is you create a thread, it's called thread, and this thread will call certain instructions on your program on certain triggers. So for example, what you can do is you can use a cron trigger, which triggers something every 5 minutes. And how it works in the backend is that there are a bunch of workers in a worker network which listen for these triggers, and then they perform the transactions. and they take the fees from a PDA that you fund, the thread PDA. And they also take 1000 lamperts per instructions. So you can use many different triggers for this. For example, on account change, you can use now, you can use a certain slot or a certain epoch or a certain timestamp. And you can also use Pith Oracle change. So this means that for example, a price of a certain token reaches a certain price, then I can trigger a transaction. You can, for example, use this to dollar cost average in a position, or you can like sell everything when you reach a certain price or something like this. Yeah, here's a bunch of use cases, recurring payments. You can use it to distribute tokens. You can use it to stake NFTs and pay out tokens. And here are some alternatives to Clockwork. There's Switchboard, Helios, and Trigger. Trigger is actually, I met them at the Berlin Hacker House again. So they are also building an automation solution. And Switchboard has a feature called functions, which can also be used for that.
Carlos, actually, you're here right now, I think.
Carlos is here. Yeah.
Carlos,
Yeah,
chill.
we
It's
talked
it's
just
your
last
time.
week. Yeah, you want to quickly talk about Trigger?
Yeah. So I think like inherently Trigger is a little bit different to what Clockwork was trying to be, but it happens to be that some of the use cases that work for games, Jonas and I were talking about them in terms of uh, account change, price, and also time-based triggers. These are things that we're using for our own sort of like applications, and the infrastructure kind of allows for this. So right now we're exploring avenues to enable these use cases for developers as well. And well, trying to not make the same mistakes that Clockwork had, to hopefully have it be something that can exist in the ecosystem for a longer time. But also, I talked with the guys that are trying to keep maintaining Clockwork today, and they seem pretty engaged, and so I'm sure that both protocols will exist in the near future for different use cases. So that's exciting.
Cool, yeah. I would also say so. The more possibilities everyone has, the better. The next thing, yeah, I wanted to show you a few games quickly. So this game here is Solana 2048, and every move on this grid is actually a transaction on Solana, and it uses all the methods I told you earlier. So you can see every 500 milliseconds, actually, we get the new tile on the board. So you can see I can actually very fluidly play this game, although every transaction, every move is actually a transaction on chain. And yeah, so this is how it's using the Clockwork thread. There's a weekly high score here, and which is currently not loading for some reason. Is my internet still there? Am I still here? Yeah. Okay, but the high score is not loading, looks like. Anyway, there's whenever you start a new game, there's a little bit of sol transferred into this jackpot here. Currently it's 0.1 sol, and every week all these all the fees that went into this pool will be paid out automatically with the Clockwork thread to the best 3 players of the week. And now I want to quickly talk about auto-approving transactions, because for a game, of course, it's very annoying if you want to do a move and then you need to, like, the wallet pops up and you need to approve the transaction. There's a few possibilities how you can solve this for your game. There's Solflare auto-approve with burner wallets. There is creating a local key pair in the browser. Then there's a thing called GUM session keys. There's a durable nonces, Clockwork threads, and signing in the backend. So having auto approval on Solflare, and 2 weeks ago, I think Phantom also added this feature. So how it works on Solflare is per app, I can go in the wallet, I can pick my app, I can say I want to auto approve for this app, and then when every transaction that I send there will be automatically approved. But you can, of course, already see that this could be also some problems. Like if you auto-approve transactions for a malicious app, then they might just drain you. The pros are it's secured by the wallet, so the wallet is safe in the browser extension. The wallet takes care of that. But the negative parts are that you need to teach everyone how to use this, right? So someone comes to your app and you think, hey, just use auto approve, but then you need to teach people, hey, you need to first of all use Solfare or now Phantom. Then you need to create a burner wallet. Then you need to go to security settings, then to auto approve, and then click OK. So this is, of course, every click in the onboarding makes people, gamers, to churn earlier. And then you also need to fund it before usage. So you create a burner wallet, then you need some Sol there. So it's not very convenient. And currently it only works with Phantom and Soulflare, but maybe they will improve it in the future. Then you can create a local key pair. So this is, for example, what we did in this game 7Cs, which I will show you directly after this auto approval session. And it has a very nice UX. So you just create a key pair in the browser, you save it in the browser DB, and then you have functionality like a little pop-up. Hey, you don't have Sol in your wallet. Do you want to transfer some? And then you use the browser extension to transfer some Sol into this in-game wallet. This is a very nice UX. It's very easy to set up. It works for all programs. But it also has some problems, of course. Like all of the solutions currently still have some problems. When the players delete their browser cache, these local key pairs might get lost. And it's saved in the browser DB, which is not necessarily safe. So the browser isn't a safe place, as you all know. There can be malicious extensions, and there can also be some cross-site scripting, or you can have a virus on your machine. So it's not necessarily safe. And this could also lead players to losing their game state when it's not handled properly. Then there is GUM session keys. GUM recently stopped maintaining the session keys, but the Magic Block team took it over, and just today, like 10 minutes ago, they posted that they also deployed a new version of this. So this is definitely still usable, and has also very nice UX. It's easy to set up, and it has a token expiry. So how it works is your main wallet, the browser extension, derives the session token. And the session token is also a key pair which is saved in your browser. But in your program, you save the authority of the game state. And this means that when this session token gets lost, then you can still access your game state like normal with your main wallet. So that's a big advantage over just having a local key pair in the browser. It's still saved in the browser DB, but this one has like very little Sol on it. And I think the Magic Block team is even working on having no Sol on it at all. And then it's basically like Web2 OS token, where you just have some token that you can use to perform certain actions on a program. And yeah, another little advantage is that the Sol that you use to fund this key pair could theoretically get lost if the client doesn't handle the refund of the Sol in there correctly. So Solana 2048, I just showed you. So every move is on chain. You can use NFTs for the game state, and rewards are automatically paid out to the players. Here a few more example games. Then this was an idea that actually I think Toli came up with. It was to use durable nonces for transactions. So this should be also quite easy to use, nice UX. But I haven't tried this out yet. So if any one of you wants to dig into how this could work, this would be quite interesting topic. The problem is that durable nonce accounts are also quite expensive. So, I mean, they can be closed again later, but yeah, if any one of you guys wants to look into how you could use durable nonces for auto-approving transactions for a certain program, this would be very interesting. Yeah, and then I talked with the Clockwork team a few months back about using the worker network to use transactions and just have a thread and then like have some kind of crank which sends these transactions using the workers. This would have the benefit that you would not have the key pair in the browser anymore, but the workers would actually sign for the transactions. But maybe in the end we can discuss a bit more about these different solutions. Then another nice solution for auto-approving transactions is, of course, the easiest is signing in the backend. It's very easy to use, very nice UX. The problem is you are paying the gas fees. So another nice thing about building on-chain games is that you can actually distribute the costs of your backend to the players because they sign the transactions. And yeah, the game is only playable as long as your backend is live, since yeah, if your backend goes down, then you can't play the game anymore. So it's not 100% on chain, but maybe that's not necessary. This is how you would use it in JavaScript. You would just have in your environment variables a burner key, and then you would use this burner key to sign the transactions on behalf of the player. So now we have a session about on-chain games. We can also have a little break and you can ask some questions. Maybe I can quickly look through the chat. Okay, doesn't look like there is anything. Okay, so then let's talk about randomness on chain, because I get this question a lot. How do I do a coin flip game? How do I build a raffle? And yeah, I often have to explain people that it's quite dangerous to use just normal randomness on chain to do money involved things. So this is the easiest way, probably, how you can do a randomness in a game. So you just have an XOR shift function, and you just initialize this with some value, and then you get a whole line of pseudo random numbers. So this is very easy to use, of course, and this is how you would use it. I used it in this 7Cs game, for example, to calculate damage. And how it's done, you just create an instance of this random file, you initialize it with some value, and then you just get the next value out of it. Then there's a bit more random function of this pseudo-random function, which uses U64. So what you do is still some XOR shift, but in addition, you add a U128 constant and then cut off the rest of the big number. But maybe we don't need to go too much into detail, but this is like a little bit more homogeneous randomness distribution. Then what you can do as well to make it even more random, like the last one was just initialized with some constant value, you can use the current slot in the program. So you can use clock.current slot, and this you use to initialize your randomness. And like this, you have very nice random numbers. What you can also use, you can use a hashing function. So it's a SHA-258 hash. You just create a new one, and then you take a few bytes of it, and this is your random value. These are also very random, but of course, creating SHA hash needs a little bit more compute. So it's a bit more expensive in your program execution. So yeah, but one thing I want to talk about is that these, if you use the block hash or any of the block functions, it's not 100% safe. So a malicious validator could, for example, fill up the block with some dust and influence the block hash in some way to validate, to change these random values. This is a very unlikely exploit, but theoretically possible. But a more common attack actually on cheating randomness, which happens quite often, is that you just add another instructions under your instruction that you do. Like let's say I have a coin flip instruction, and then I add another one, and in the other instructions I check if I won or not. And if I didn't win, then I just let the whole transaction fail. And like this, you can very easily yeah, circumvent random outcomes if they are not in your favor. And this you can solve actually quite easily in the program by checking if there's no other instructions in the transaction by using the sysvars. But even that can then be cheated, which I recently learned, because G2, like the second validator client, offers a thing called transaction bundling. And this makes it possible that you can have a transaction fail if another transaction doesn't want it to succeed. So yeah, randomness is very difficult, and the only solution, the proper solution, is actually to use an oracle. And for example, Switchboard offers randomness solution. And so what it means basically, your transaction goes through, you save all the state, and then you depend on some oracle to do a CPI into your program. and inject some data from outside, and this is then used to calculate the randomness. And the switchboard, had very nice randomness function. There is a tutorial on that, which I linked somewhere in the slides if you want to look at it. There's a coin flip, which actually uses the switchboard randomness functions. And yeah, that's what I already said. Like Oracle does the CPI into your program with the random value, and you also need to pay for switchboard a little bit. Here are the resources for if you want to dig deeper into randomness. And now I want to maybe have a little break and show you this game here, because it's like probably quite maybe a bit boring to only look at the code. So this game is called 7 Seas. We built it as an example game for the bootcamp in New York. And if someone wants to join in, I quickly paste the link here in the chat. This is on DevNet, by the way. The Solana 2048 is on mainnet. So, and what you can do here, this is a 10 by 10 grid, and every move again is a transaction on the chain. And if I now collect this chest here, then I will get a little bit of SOL, and I also get some SPL tokens. And these SPL tokens, then I can also use to upgrade my ship. And when I scan this QR code here in the top, then it's doing a Solana Pay transaction request again. And let me quickly show you that. So then this Cthulhu guy here shoots at the closest ship. So we can have like a big sea battle here, and the Cthulhu, like the audience, can scan these QR codes and then influence the game like that. Okay, back to the slides. So this is this grid is actually saved in one big account, and there are a bunch of limitations on accounts on Solana, and you might hit these limits quite quickly if you start programming your game. And these limits are, you have 10 kilobyte account size limits when you create a normal account. And you have 10 kilobyte stack size and a 32 kilobyte heap size limit. And the maximum account size is 10 megabytes. But if you want to create an account which is bigger than 10 kilobytes, then you need to use a zero copy account. But the first thing I want to show you how you can save some stack size actually, is you can box your accounts. So if you ever come to the point where your account becomes bigger than these 4 kilobytes on the stack, you can just box the account and then you move it basically from the stack to the heap. And this is how you can increase the account size to more than 10 kilobytes. This is, for example, needed for this sort of 7 Seas game here. This is a 10 by 10 grid, and this is, of course, way bigger than 10 kilobytes. So what we need to do then is we need to increase the account size a few times, and then we can use this account. And here on the playground, I added a link here if you want to try this out. Then there is a tutorial that you can just run in the browser in case you ever need a bigger account. So I will not go too much into detail here now on how this actually works, but you can check this out in Playground and just deploy it yourself. So this is used. This is how it's used in the 7 Seas. So it's just a two-dimensional array of tiles, and every tile has the player public key. It has the current state of the tile, the health, the damage, the collect reward, and the avatar. The avatar is an NFT, so it can just be any NFT. Here you can see this is the NFT of this ship, and this is the NFT here of the other ship. So it personalizes your game account a little bit. And this is one of how one of these grids is, how you can build one of these grids here, because there are multiple solutions on how you can build a grid in the game. So as I showed you here, we have a 10 by 10 grid, which has all the data of all the accounts in it. But recently I played another game. This one is called Z Wars. It's a zombie versus humans game. and I can move around on this grid here. For this one, I enabled auto approve, like I showed you earlier. So you can go here to settings, security and privacy, manage apps, ZWords, and then you can just say auto approve. Yeah, and I can walk around on this grid here, and I can eat humans, I can break down barricades. And this grid is built a little bit differently. This grid is built by, this is way bigger than the 7 Seas grid. And in this game, actually, every tile is its own PDA. So every tile has coordinates, like 1, 1, for example. And then, yeah, whenever you move, all the surrounding tiles are requested from the RPC node. And this has some advantages and disadvantages, which I want to show you now. So if you just have your whole game state in one account, it makes it very easy to listen to this account via WebSocket. So on the 7Seas game, it's just one account, it's the grid. We are listening to it via WebSocket, and whenever someone moves around and anything changes, we get an update. And you cannot have any desyncs, and you get very fast updates. The only problem is the size limitation that I talked to you earlier. At some point, we will hit the 10 megabyte limit. And even if you just have a few megabytes, already the traffic will be huge that is being sent to every player when anything changes. And yeah, what the ZWords does is quite interesting. They're using a PDA per tile, which means it's infinitely scalable. I could theoretically have 1 trillion tiles. As long as I only get the tiles around me, it's no problem. The problem they have now is that they have quite high RPC costs, because whenever you move around, you need to request all the tiles around you, and you need to request all the information of all the players on these tiles. This is something that's not needed on a game if it's programmed like this. And yeah, the cost can become quite high. Like on Helios, for example, I think you get 30 million for free with the hacker plan. And yeah, these you reach at some point if you do it like this. And yeah, but I think the RPC cost will probably come down in the future. Like for example, currently it's about 10 times more expensive than Firebase database. And I guess if you go to higher RPC plans, then maybe it even lowers the cost to be more similar to Firebase. Yeah, so these are two options how you can build a grid. And now I want to show you how you can do on-chain events. That's also something that you usually need when you build a game. Like you can see here, for example, when I shoot, you can see that there are these cannons shooting to the left and right. So if I move next to the ship and I shoot, then I see here, okay, this one got 2 damage, and there's cannons shooting, and there's like a little blimp flying up that shows the damage. This sounds trivial, but usually when you just listen to the count of the grid, then you just go from one state to the next state, and you wouldn't know what happened in between. So you need some kind of way how you can have certain events that happened in the game and show them in the clients. And I want to show you 2 ways how you can do this. There is one way which uses anchor. Anchor in Rust has the function to emit an event. So just emit my event, and then you add the data. And what this does is actually in this transaction, it writes this data here into the ledger. So basically into the transaction logs. That's the same way how count compression works actually. Like compressed NFTs, what they do is, to be cheaper, is they just save all the data that's needed for the NFTs in the ledger. And this emit anchor function here does the same. So it writes this data into the accounts, and then you can do from your anchor program, add event listener, and then you can add the name of the event, and then you can listen to this event and then do certain things. So this is, for example, what ZWords does here. When I do something and I can see moved successfully. This is an event which is triggered on chain. And 7Seas does it a bit differently. because this has also, again, advantages and disadvantages. It's quite easy to implement, but there is no filtering for these events. So whenever I send this event, my event, I will get all the my event events, and that's maybe not what you want. So I'm still hoping that this event structure actually improves a little bit on Solana, because it's a very good feature to have for games, especially. So this is how it was done in 7Cs. It's just a manual way. So there is a game actions account, and the game actions history account has a vector of game actions. So whenever something happens in the game, we just push a new game action into this account, and all the clients are listening to this account, and then they can show the game actions as soon as this happens. So in every game action has an action ID, an action type, and a player and a target, and in this case also a damage. And then every time one of these actions is pushed, just a few of the old actions are thrown out. So this has the advantage that we can play forever, and we can very specifically say which events we want, we can filter them, and this account has always a constant size. So it always has the same size, and whenever we have more events, then we just throw the last events out that we don't need anymore. Do you have any questions about events or about building the grid or big accounts or any of that? All right, then let's go on. Solana game example. So I'm gonna put this in the chat. There's a bunch of examples if you want to get started with game development. Like all the games that you see here, they are also in the game examples. The Solana 2048, the Tug of War, the 7Cs. So whenever you want to do something that's similar in functionality, then you can just look at the game examples and copy paste over the code that you need. For example, when you ever need to derive a game state of a pirate ship from an NFT mint, then you can do this. Or if you want to know how you can pay out a rod as a SPL token whenever you kill another player in a game, then you can also just look at the code and copy that over. So then, yeah, quick intro into the Unity SDK. The Unity SDK currently maintained by Magic Block has the same functionality basically as the Web3.js. And yeah, you can send transactions. It has wallet adapter. Now they're maintaining the session keys as well. It works on mobile, on WebGL. There's also an Unreal SDK, which I think I have the link in the resources later. So that you can also check out. There's also an engine for the Godot engine. There is Svelte game engine. There is a Turbo game engine, which is currently being developed by someone from Phantom, which you should definitely check out. There's a little game jam coming up soon. So if you like Rust and you like building small little games, then you should join that one. Then, yeah, here's a bunch of resources. And then here is some example games that I would go through now if there are no questions, since we are hitting the end already.
I think we have to wrap up now because we only have 5 minutes left.
Yeah.
If there's nothing super relevant that we'd have to show, otherwise maybe you can go through still. But is it good or?
Yeah, I mean, I can quickly show a few minutes of games like there's Star Atlas. There's Solana Plays Pokemon, where people play a Pokemon game together, and on the bottom of the game you vote for the moves in the game. Then there's Chrono Kingdom, completely on-chain game where you build up your city and you can attack other players. Then there's a very interesting open source Opus submission from the last hackathon. It's like a mixture of Age of Empires and Stronghold. So you build a completely on-chain city as well, and you gain SPL tokens by playing it. There's a Soul Civilization game on-chain. Then there is a Diablo game, which is currently developed by Into the Verse called Intrant Infernus, which has some permadeath, and you can use some NFT potion to revive yourself. Then there's Human versus Goblins. It's a multiplayer city builder where you actually build all together the same city, but you can also decide if you want to play evil or good. And yeah, most of these games are open source, so I'm just showing them so that you can like have them as resources. Deez Quest has a very interesting on-chain matchmaking. So it's a multiplayer match 3 game where you play against each other, and all the matchmaking is also on-chain. So yeah, if you have any questions, I still have 3 minutes left.
Do we have any more questions? 3,
One.
2, 1. All right, looks like we don't have any questions. Before you guys leave, I want to make one very important announcement, and I also want to thank you, Jonas. Of course, it was a really great session. Like, I didn't know anything about games on chain games before, and like I feel like I already shipped 2 or 3 games now after the presentation. So really quick, sharing my screen as well. So I hope you can see it.
Mm-hmm.
Now, what we're going to have in a bit or in a few weeks is Build Station. If you don't already know it, Build Station is a 3-week-long co-working space where builders, enthusiasts, artists will get together to just ship some cool stuff. And what are we building for? Of course, the Hyperdrive Hackathon. And we got it all, free snacks, monitors, setups. It's all there. So you just gotta come, plug in your laptop. The food is also there. So, but the highlight of it all is that we have a demo day, a local demo day with 17 local prizes and like a total prize pool of 30K. So you actually have like a really good chance of winning something, even if you don't win at the global hackathon. You have a good chance at winning something at the local demo day. And so projects like Bunker Trigger, Soul Lightning, and many more that you probably already heard of as well were built and demoed during the last build station. So if you want to join us to build some crazy things, come to Berlin. I'm going to send the Luma into the chat. There you go. So I highly recommend you to sign up. It was definitely one of the like best time of my life last year. So yeah. And if there's nothing else you would like to say, Jonas, or anybody who has a question in mind, question that appeared.
Thank you very much for having me.
Yeah, sure. Thanks for presenting.
Have
All
a
right.
good evening, everybody.
Then I guess see you all on Thursday with Noah on decentralized physical infrastructure. Yeah.
Thank you, man. Ciao, ciao. Take care, guys.
Take care.